Welcome back to Everyday Mathematics. Today we're going to be solving the first 5 problems from the 2025 AMC 10A. So let's start with problem 1. Andy and Betsy both live in Mathville. Andy leaves Mathville on his bicycle at 1:30, traveling due north at a steady 8 miles per hour. Betsy leaves on her bicycle from the same point at 2:30, traveling due east at a steady 12 miles per hour. At what time will they be exactly the same distance from their common starting point? So we have stuff with time, we have stuff with rates and stuff. So whenever we see a problem like this, the formula that we want to default to is distance equals rate times time. And we want to find the time when they're exactly the same distance from their common starting point. So basically, we can write this distance is equal. So therefore, we can just say that the rate at which Andy is biking times the time for Andy is equal rate of Betsy times the time of Betsy, because both these are RT and the rate times time is going to equal the same for both of them. So let's start with which of these variables we can replace. So rate, so let's look at Andy. Andy is traveling at 8 miles per hour, so we could put 8 for rate. Time, this is a bit tricky. So we have to look at what time means. So we're going to let 1:30 be the point when t equals 0. So the time since 1:30, so Andy is starting to bike at 1:30, so just 8 times this variable t. Now looking at Betsy. Betsy is traveling at 12 miles per hour. But Betsy starts an hour later. So the time that Betsy is biking is going to be the time that Andy is biking minus 1. Now we perform some algebra. 8t equals 12t minus 12. Therefore, 4t equals 12 and t equals 3. Now we have to remember what t means. So looking back, t equals 0 is 1:30. So at t equals 3, this is when they're at the same distance, travel the same distance. The time is actually 4:30. So our answer is E. Moving on to problem 2. A box contains 10 pounds of a nut mix that has 50% peanuts, 20% cashews, and 30% almonds. A second nut mix containing 20% peanuts, 40% cashews, and 40% almonds is added to the box, resulting in a new nut mix that has 40% peanuts. How many pounds of cashews are now in the box? So with AMC problems, it's typically good to know what direction we're going to take these problems and what formulas we're going to use and how we're going to approach it. So dealing with stuff with this, percent peanuts and stuff, percent of something. Percent is basically what it is, it's the amount of that specific thing over the whole. So initially, the new mix is going to have 40% peanuts. And so 40% is equal to 2/5. So this is our ratio of amount of peanuts over all the nuts. So in our mixture, how many peanuts are we going to have? So this box already contains 10 pounds of nut mix that's 50% peanuts. So it's already going to start with 10 times 50 over 100, which is 5 pounds of peanuts. And then the whole, you're already starting with 10 pounds. Let's say we add X pounds, this variable that we're going to try to find, X pounds of the second nut mix. So that means our denominator, the total is increasing by X. How much does the amount of peanuts increase? Well, if we look back at the problem, this mix contains 20% peanuts. So therefore, the amount of peanuts is going to be 1/5 times X, because 20% is 1/5. So now we have our equation. Now we just do some algebra. So 25 plus X. So X equals 5. And what is X? X is the pounds of the second nut mix. However, is that what we want to solve for? Not quite. look at the back of the problem. How many pounds of cashews, not of the new mix, that are now in the box? So we have 10 pounds of the original nut mix. And this is 20% cashews. So 10 times 20%. And then we have 5 pounds of the other nut mix. And this is going to have 40% cashews. So that's going to be 2 plus 2, which is 4. So our answer is B. 4 pounds of cashews. Next, we're moving on to problem 3. How many isosceles triangles are there with positive area whose side lengths are all positive integers and whose longest side has length 2025? So, again, like all the other problems, what relationship are we going to use to solve this problem? Well, we know the longest side has length 2025. And since we're dealing with, we want to find like possibilities for the other sides. So there's some relationship that has to be true. And this is actually called the triangle inequality. Which states that the sum of any two sides of a triangle is greater than the third side. So we have this longest side is 2025. So in most cases, this 2025, well, in all cases, this 25, so basically what we want to find two other lengths. And the thing is, it's isosceles, which means that two or more, at least two of the sides have equal length. So, what is the so if we let these two sides, we want to let's find the minimum value of these other length of these other two sides. If we let both of them be a plus a is greater than 2025, then we can find that the min value of a, the minimum value, is going to be 1013. And then, so a can be 1013, right? It works for 1014, so on. And it works on all the way to 2024, right? Because 2024 plus 2024 is greater than 2025. And this makes sure that 2025 is still the longest side length. So we have these cases, and this is when 2025 is not the side that has another side that's congruent. But then, like this isosceles triangle, if there's 2 times 25, so if you have like this isosceles triangle and two of the side lengths are 2025, then what can the side length be? Well, using triangle inequality, we want to find the bounds, right? So minimum, the min value, min length, is going to be, it can be 1, right? Because 2025 plus 1 is greater than 2025. And since they're integers, and the max length, well, this is just bounded on a constraint that 2025 is the longest side, right? Any other value, because 2025 plus any other number is going to be greater than 2025. That's so 2025, which is actually an equilateral triangle. So in our first case here, when 2025 wasn't the side that had another side that had the same length, we have a amount of 2024 minus 1013 plus 1, which is, 1012 combinations, or possibilities for this case. In this case, between 1 and 2025, there's 2025. So total amount of triangles, 1012. And we're not overcounting because we separate our cases into when 2025, there's only one side that has length 2025, and when there's 2 or more sides that have length 2025. So we get 3037. So our answer is D. Moving on, problem 4. A team of students is going to compete against a team of teachers in a trivia contest. The total number of students and teachers is 15. Ash, a cousin of one of the students, wants to join the contest. If Ash plays with the students, the average age on that team will increase from 12 to 14. If Ash plays with the teachers, the average age on that team will decrease from 55 to 52. How old is Ash? So, in a way, this problem is quite similar to problem 2. in that, right, we're dealing with averages. So it's part over whole, right? Actually, never mind, sorry. Well, we're not part over whole, but we're going to be wanting to use division, right? As in percent is part over whole. Average is equal to the sum of the ages, because we're dealing with ages, divided by the number of people. So it's similar to number 2, as in the fact because we have this division. Okay, so let's look first with the students, with Ashley's with the students, right? Oh, and the first thing we want to do, right? The total number of students and teachers is 15. So let's actually split that up because we have our two equations. So let there be x equals number of students, and therefore it follows that 15 minus x equals the number of teachers. So let's look at for the students. Right, so so how many people are there going to be when we're calculating this average? Well, there's x students, and we're going to add to Ash. So x plus 1. And this new average is going to equal, 14. If there are x students, and the average age among those students is x, then, right, we can plug into this equation. If the average is 12, and we want to find the sum, there's x students, the sum is just going to equal 12x. So you can put a 12x here. And then, we need a variable for Ash's age. So let's let A equals Ash's age plus A equals 14 times x plus 1. Similarly for the teachers, we do the same thing, right? This new average is going to be 52. And then we have 15 minus x, because there were 15 minus x teachers, plus 1, Ash. And similar to how we found 12x, the sum of the age of all the teachers is going to be 55 times 15 minus x plus Ash's age. So I'm actually going to erase this calculation, just so we can do it for the algebra. And now we're good to go. So let's multiply stuff out. So we have 12x plus A equals 14x plus 14. And for the teachers, it's a bit more. We have 825 minus 55x plus A. And then we have 780 minus 52x plus 52. Let's rearrange both sides. We have a 2x. Oh, we actually let's solve for A. A is going to be 2x plus 14. And this side, right, the 780 and the 52, you're going to get an 832. So you can say A equals 3x plus 7. Where x is the amount of students. We can set our values of A equal, so 2x plus 14 equals 3x plus 7. X equals 7, so therefore A equals 2 times 7 plus 14, which is 28. So our answer is A. Moving on to problem 5. Consider the sequence of positive integers 1, 2, 1, 2, 3, 2, 1, 2, 3, 4, 3, 2, 1, 2, 3, 4, 5, 4, 3, 2, 1, 2, 3, 4, 5, 6, 4, 3, 2, 1, 2. It's kind of going up and down and up and down and up and down, but it's going higher up to a higher up integer every time. We want to find the 25th term of the sequence. So this is a type of problem that the AMCs have quite often, where there's this sequence or this something going on, and you want to find like the year, 2025, 2024, whatever the year is. But it would take quite a lot of work, especially for a 75-minute test, to actually compute the 25th term, and it's just prone to mistakes, and it's not very efficient with your time. So the method for almost all these problems is to find a pattern, right? So we can kind of have this pattern. So we have like 1, 2, right? So we have this block. Then it goes 1, 2, 3, 2. And I'm not including the 1 at the end because it's not there. And it goes into the next one. So 1, 2, 3, 4, 3, 2. It can go 1, 2, 3, 4, 5, 4, 3, 2. An interesting thing to notice here, if you want to count the amount of terms in each like group of this pattern, there's 2, 4, 6, 8. And let's let this be like the n, which is like the nth grouping in this pattern. So for the nth grouping, we can say the max is n plus 1, and the number of terms is 2n. So basically, so this is like the pattern that we found. Now we want to find how many groupings are there before we get to like close to 225. So basically what we want to say, right, and the sum, let's find the sum of number of terms of first n groupings is going to be, right, so we have 2 times 1 plus 2 times 2 plus dot 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 plus 2 times n. And using the sum of the first n integers, right, it's just 2 times, we can factor 2 out. It's just n times n plus 1 for 2. Which is n times n plus 1. So that's like the sum. Now what we want to do is we want to find when the sum is the max value of n such that the sum is less than 2025. This is n squared plus n is less than 2025. So here's a good thing, and it's always good to know the prime factorization of the year or any facts about the year before you take the AMCs, because they will show up more likely than not. 2025 is 45 squared. So that means 45 doesn't work, but 44 does work. So 44 squared plus 44 is going to be 1980. 1936 plus 44, which is less than 225. While like when you go 45 squared, then it's going to go up further to 2070, I believe. So right, we have 4. So it's going to go up. It goes up and down to 1, 2, 1, 2, 3, 2, all the way up to 1, 2, 3, 4, all the way to 44, then back to 3, 2. So this next up and down is going to go what's up to 44, 45. And we want to find, wait, how many terms left do we have? Right, 2025 minus 1980 is 45. So we want the 45th term from this group. It's just going from 1 to 45 and back down. The 45th term is just going to be 45. So our answer is E. Those were the solutions to the first 5 problems from 2025 AMC 10A. Hope you enjoyed and hope you were able to learn something from it. And yeah, see you.